In the movies, jumping to light speed is a gentle, beautiful experience. The stars stretched into glowing white lines as you coast into the cosmos. But the reality of physics is much more violent. We are going to run a thought experiment to see what your eyes and body would actually process if you accelerated a ship toward the absolute speed limit of the universe. The core problem we face was outlined by Albert Einstein. Human intuition is built for a flat, three-dimensional Euclidean world, but the universe operates on curved, non-Euclidean spacetime. At these velocities, you aren't simply changing coordinates. Your brain and eyes are forced to process a reality that has been physically warped by your own momentum. At 50% the speed of light, the first thing you lose is your ability to see color normally. As you plunge forward, you experience the relativistic Doppler effect. Light waves ahead compress into shorter, higher frequency wavelengths, shifting starlight toward the blue spectrum. Meanwhile, waves receding behind stretch into longer, lower frequency wavelengths, shifting them toward the red spectrum. But these shifts are so extreme that they push the surrounding starlight out of the human visible spectrum entirely. The stars ahead become invisible ultraviolet radiation, and the stars behind become invisible infrared radiation. Coasting at half the speed of light would not give you a brilliant cinematic view of the galaxy. It would plunge your forward and rear windows into complete darkness. Push the throttle to 90% the speed of light, and the geometry of space itself begins to bend. You encounter relativistic aberration, where the physical angle of incoming light changes based on your velocity. Because you are moving so fast, photons from the sides, and even from behind the ship, warp forward into your field of view. This concentrates all the incoming radiation from the surrounding universe into a blindingly intense cone directly ahead of you. You are effectively seeing behind your own head. If you passed a large physical object at this speed, you might expect it to look flattened due to length contraction. Instead, you experience what physicists call the Terrell-Penrose effect. Because the speed of light is finite, the light from the back of the object has to travel a longer distance, meaning it had to leave the object earlier to hit your eye at the exact same moment as the light from the front. This creates a powerful optical illusion where the object appears physically rotated. Near the speed of light, space acts like a funhouse mirror. It aggressively distorts incoming geometry and breaks your standard understanding of shape and position. At 99.9% the speed of light, the visual illusions stop mattering. You are now facing extreme physical hazards. Space is not entirely empty. It contains a near vacuum of trace gas and dust called the interstellar medium. At this velocity, that scattered dust transforms into a devastating headwind of relativistic particles hammering your ship's hull. Then there is the cosmic microwave background, or CMB. Normally, this is just harmless ambient heat left over from the Big Bang, resting at a few degrees above absolute zero. But plunging into that background radiation at 99.9% of light speed blue shifts those microwaves. They compress into a concentrated, lethal beam of X-rays and gamma rays focused directly on the ship. This chart graphs the radiation hazard for relativistic flight. Looking at the solid line tracking the dose rate in rems per second, you can see that as the velocity approaches the speed of light, the radiation spikes exponentially. It delivers a lethal dose to a human body in a fraction of a second. The faster you go, the more the cosmos weaponizes its own emptiness against you. Approaching 99.99% the speed of light, you hit the hard mathematical boundary of special relativity. Any object with mass requires infinite energy to reach light speed. To finish this thought experiment, we have to explicitly break the laws of physics. We must strip the ship and the traveler of all mass to cross the final threshold and hit exactly 100% the speed of light. As a massless entity, you now share the perspective of a photon. This introduces a relativistic concept known as proper time. Proper time is what a clock actually measures along the physical path an object takes. Because massless particles always travel at the speed of light, they do not possess a rest frame. For a photon, the internal clock stops completely. At the speed of light, time itself ceases to exist for the traveler. The journey's beginning and end occur at an absolute simultaneous instant. We end the experiment by decelerating back to normal space, returning our massless traveler to the starting point of Earth. Here we find the tragic consequence of time dilation. While the journey took literally 0 subjective seconds for the traveler, the rest of the universe's clock kept ticking. Thousands or even millions of years have passed in the universe's coordinate time. Everything and everyone the traveler ever knew has turned to dust. The universal speed limit is a cosmic double-edged sword. It prevents us from surviving the violent extremes of the universe, but it is also the only thing anchoring us to our localized, shared pocket of time.